So from the concept of dipole, there was a keyword like dipole. So I will have to at least remember or know or find first which chapter has dipole related concept. So this is the place, and I will do a quick search. Control F, dipole. So once I reach that point, okay, this is the dipole. Okay, and dipole talks about electric flux and all that. Electric dipole. This is the section where I have dipole for points on the axis and for points perpendicular to the axis. These are the two things. Points on the equatorial plane. The magnitude of electric field due to the two charges are this, right? Okay. Now this whole concept can be reread, but if I have to find the answer to my specific question, I will just look for something similar. Okay, dipole moment is what? Q into 2a into dipole. This P is a position vector. Okay, electric field is here. Now, is it talking about work done anywhere? I mean, I'm just randomly searching. Okay. So let me now search for work. Work done in dipole. I will not find it here, right? So I will have to read the chapter and try to find out what is the relationship between dipole and work done, etc., etc. Right? This is where I will have to go back to the chapter and read related concepts. I may not have to read the entire chapter, but I need to know now everything about dipole, right? Okay. So this is how we will learn. From now on, this is how we should learn. Instead of trying to remember everything, learning everything, because we don't have that much time left. We will look into the problems and look for solutions for those specific problems. Okay? Okay. So, okay. Okay, so tell me, what is electric field in dipole? What is electric field? What is electric field in general? You have learned about magnetic field lines in electromagnetism, and in electrostatic you have learned about electric field. So what is electric field?
Force experienced by a
Point charge. Very good. Yes. Force per unit charge is electric field. Okay, or force created by a unit charge due to force experienced by a unit charge due to another charge present somewhere. Okay, that is a electric field. Now force is there. What is work? What is work? General work in mechanics. You have learned about work in mechanics, definition of work. Work is the energy spent in moving something from one point to another point, right? If there is a displacement, there will be some energy consumption. Okay. Energy consumed in moving certain thing from one point to another point. That means to move something, you will have to apply a force. Okay. And by that force, how much displacement happened? The multiplication of that is called work. And that is also equivalent to energy. Energy consumed in moving something from one point to another point. Now, if you are moving a charge from one point to another point, there also you will spend some energy, or you will require some energy to move something from one point to another point. Now, here you have a charge and you are moving it from one point to another point. Let me come back to the question paper. Where is that question paper? Did I close it? Yeah, it is here, right? I have to move something from point A to point B. A charge Q is moved from point A above the dipole to point B, right? Now, this is experiencing a force, okay? Any charge here will experience a force that will be equivalent to what? Dipole moment multiplied by, force experienced because of this negative and because of this positive, right? So force is continuously changing as this will move, right? Force will change because the distance is changing, okay? And then the displacement is there, okay? So now let's find out what will be the work done here. Work done is equal to, for the case of electricity, change in potential or difference in potential. And if there is no difference in potential, that means there will be no work done, right? So let's try to find out if there is a difference in potential if some charge is being moved from one point to another point in equatorial plane. That means a plane which is equidistant from both the poles of a dipole. So now we have got a lot of clues what we have to do. Okay, so if I can justify in case of dipoles, if I can justify that in the equatorial plane the potential doesn't change. Okay, so what is potential? Potential is the energy required to move a charge from one point to another point. Now if I have to that is the potential difference, by the way, but if I have to find the potential at any point, I need to know what is the amount of work that I have to do to move that charge from infinitely distant away, infinite, to this point. And if I have to find the potential difference, that means, okay, I have to move this charge from this point to next point. How much additional work that I have to do? Now, if all the points are having the same potential, that means I practically have to not put any work or not consume any energy to move that charge from one point to another point where both the points have the same potential. So if I can find out that in a equatorial plane of a dipole, potential is same at all points, I can straightforward say that there will be no work done because point A and point B both are in the same equatorial plane. So let me do a quick internet search because finding it in the textbook is difficult. So can I say potential in an equatorial plane of a dipole same electric potential of dipole at equatorial plane. Okay, now I got some clue directly. So let's try to find out. The electric potential at equatorial plane of a dipole is zero. Then it does not require any work for moving a test charge from infinite to that point, and I think work done is zero. If this is true, then will a free charge will sit there? This is a question, right? If you calculate the potential function, you will find that gradient of the potential at the equatorial plane is not zero. So the force is not zero. Charges can only sit at minimum of potential energy. A zero potential might not be a minimum or maximum. The reason no work is done by the field as you move the charge is that the force is perpendicular to the direction of motion. Now, this is interesting fact. So whatever force, what happens here is, let's come back to the question. Where was the question? Here. Okay. Now force that gets applied on a charge here. Suppose I have a charge. Okay. I have a charge, say point A. Here I have a charge. The force applied here will be in what direction? It will be from this point. Suppose this is a positive charge. So this is negative and this is positive. Okay. So what will be the direction of force? Attractive force or repulsive force? Attractive, because these are opposite charges, right? So attractive force will act in this direction, right? Okay. Then you have another charge here. So this is also putting up a force, right? What will be the direction of this force? These are both positive, so repulsive force, correct? Now here the direction is this, here the direction is this. Okay, what is happening is both the forces amount wise are equal, but these are in different direction. So force is a vector, right? So what I will have to do is, okay, so this is one force and this is another force. The charge at A is experiencing two forces, and now I have to find, okay, what is the equivalent force? So it will be somewhere here, equivalent. So we can do a vector sum and find the equivalent force. Because the quantities are same, we can validate that the angle made by the resultant with these two will be equal. So it is like dividing, it creates an equilateral triangle, right? So equilateral triangle means this equivalent will be perpendicular bisector of these 2 points, something like that. You have a triangle where two sides are of equal length, and then you add these together. Equivalent will be this side, which is a perpendicular bisector, and bisector means these angles are also same, right? So what happens here is this equivalent force becomes parallel to the pole's length. Okay, now what is happening? Force is like this and displacement is happening in this direction. Okay. Work is what? It's a scalar product of force and displacement, right? It's a scalar product. That means F into d into cos theta, right? Theta is the angle between these two vectors. Now, what is the angle between these two vectors? This is f, direction of f, and this is direction of d. This is direction of f. Angle between these two is 90 degree, right? Because this is perpendicular to this line and this is f is parallel to this line, right? Now, cos 90 degree is what?
One.
Cos 90, sin 90 is 1. Cos 90 is 0, right? So cos 90 is 0. So this will become f into d into cos 90,
Zero.
and cos 90 can be written as 0. So whatever may be the value of f and d, net value of this will be 0. So work done in this case becomes
Zero.
right? So now all this is so much of concept, but from now on you can remember a one simple fact that if you have a problem like this, if the charge is asked to be moved in an equatorial plane, now this is a keyword that you will have to remember. A charge q is moved from point A above a dipole to dipole moment 2, p, to a point B below the dipole in equatorial plane. Now this is the keyword. If the movement is happening in equatorial plane, the angle between the resultant force, because of these attractive force and repulsive force, and the displacement, the movement, direction of movement, are perpendicular to each other. And because those are perpendicular to each other, cos theta or cos 90 is 0. So multiple of force into displacement will always be 0. Whatever may be the force, whatever may be the displacement. It never said what is the distance traveled, A to B, what is the length. Without that, I can't really calculate the distance or displacement. So the problem itself gives enough hint, and then more importantly, this is a 1 marks problem. So a lot of hints are there that it is not a difficult problem. It should have a ready-made answer. I don't have to really solve this problem. So the answer is 0.
Zero.
So at the beginning, I told you the answer for this will be 0, but how? This is how. What is the reason? The displacement and force are perpendicular to each other. So it's a dot multiplication vector, scalar product was 90 0. So resultant is 0, right? So you will have to act smartly in the exam. Look for the problem. How much marks? Then you can make a guess how complicated the answer could be. It will be, if it is a less marks problem, generally the answers will be straightforward. And that means you will have to just recall your knowledge. You don't have to do any much, put any calculation, do any calculations, and you will be able to get the answer quickly. Okay, next question. In what way is the behavior of a diamagnetic material different from that of a paramagnetic when kept in an external magnetic field? Diamagnetic versus paramagnetic. So what is the behavioral difference when it is put in an external magnetic field? Now, this is a very straightforward question. If you know what is diamagnetic, if you know what is paramagnetic, you will be able to answer that, right?
Paramagnetic is strongly attracted by the magnet.
Paramagnetic is, yes, that gets attracted. Diamagnetic is
Diamagnetic is weakly attracted.
huh?
Weakly attracted.
Deeply attracted.
Uh,
And paramagnetic?
strongly attracted.
Deeply and strongly. That is the difference.
So diamagnetic means weakly repelled by the magnet.
Weakly. Okay, weakly. I was hearing deeply. Okay, right. So that is where I was surprised. So paramagnetic, para, as the keyword para says, para means parallel,
Yes, sir.
very close, similar, right? Running in parallel like that. So it is close, it is family, it is like it likes magnet, right? So from the English, I can make a guess. Dia means diagonally or like perpendicular, right? Diagonal is like a perpendicular. So diagonal means I will go in a very different direction than parallel, right? Parallel is like, okay, I will go along you, I will follow you, and dia will say, no, I will go a perpendicular to you. If you go south, I will go north. South and north are like opposite, but
Yes.
here it says, well, I will not go north, I will go east. I will not at all follow you. So that is diamagnetic. So weakly attracted and para is attracted. Right? So very simple answer. And even if I don't know, if I know the English, I can make a guess easily what will be what. Okay. Next. Next question.
So what is
Name.
the answer for that, sir?
Huh?
The second answer what, sir? The second question, what is the answer, sir?
So answer is diamagnetic material are weakly attracted to the external magnetic field. Paramagnetic material are highly attracted to the external or influenced. I may say influenced because that they will get their position changed. Diamagnetic will not change its position. Paramagnetic will start moving around. And ferromagnetic are very highly attracted or influenced, like iron.
Kept in an external magnetic field mean external mean what, sir?
External magnetic field like a external magnet. If you put a magnet in, you have a magnet, and near that, if you put a nail, then nail is made up of iron, and iron is ferromagnetic. Or if in this case, it may be paramagnetic. But if you put a say wood, a small wood, that is diamagnetic. That will not get attracted to the magnet. It will not change its position even if the largest of magnet is present. Right? So that is the difference. Okay. Next, go to the next question. Name the essential components of a communication system. Now, communication system, which chapter?
Communication system only, sir.
Yeah, there is a chapter, last chapter, part 2, I believe. Okay, let's go and find that out. Part 2, communication systems. Okay, and it should be straightforward, easy. Elements of a communication system. Section 15.2, elements. So, what are the elements?
Transmitter.
Source, transmitter, channel, receiver. Right? So,
And
transmitter, channel, and receiver. These are the primary elements. Right? That's it. That's it. That's the answer for this question. Name the essential components. Why does sun appear red at sunrise and sunset? Okay. Now, which chapter can have answer to this? It is somewhat related to light, right? Color, color, color of light. Now, where is the color of light explained and the behavioral differences of color of light? So, first thing is about light. Light means refraction, and several other things related to light, waves, correct? All of those chapters. So, you have 2, 3, and maybe 4 chapters related to light. But this question is 1 marks question, so it will definitely not be that complicated. It should have a simple and straight answer. Okay. So try and find that out. It is one hint. It is about refraction, and it is about refraction, say in spectrum, where the white light, gets split into multiple colors, which we call, what we
Uh,
call, Vibgyor, the rainbow colors spectrum, right?
spec-
We get a spectrum of color, and on one end of the spectrum you have red, another end you have violet, Vibgyor.
answer.
Vibgyor school, remember that. Vibgyor school is short form of violet, indigo, blue, Vibgyor. G for green, yellow, orange, and red. Vibgyor. 3 and plus 4, 7 letters. Okay,
Yes, sir.
and that are the initial of the colors of the spectrum. So one end is violet, another end is red. So this is talking about red. And also you know that sun is farthest from us during sunrise and sunset. It is closest to us when it is just above us, right? During the day, midday. And that is when the temperature is the highest, right? When it is closest, so temperature will be maximum. When it is farthest, temperature will be less. So in the morning and the evening, you feel less heat, right? So which color light will get the maximum bending?
Red.
No, violet gets the maximum bending because the wavelength of violet is less. Now, if you can recall the spectrum, when you pass the light in through the prism, you remember I have explained, it gets split into seven colors and multiple bands of colors. So from top to bottom, actually from bottom to top, the colors are like Vibgyor. Bottom is violet and top is red. That
Red.
means if red is at the top, it gets least deflection, least refraction. Violet bends maximum, right? It goes here and bends further down. But red goes and bends but little bit relatively, and then remains almost straight, right? So if red is not bending, that means it can travel a longer distance without getting invisible. If something bends, it will hide, right? It came and it will go into the box more quickly. So it will not reach your visible height, maybe, or your eyes will not reach your eyes. That is the reason, because red color gets has so now I have to answer technically. What is the technical answer? Red color has the least refractive index, or if I don't remember that term, I can say the red color experiences the least amount of deflection among all other light colors. So red color is visible to farthest point compared to other colors. See, as the sun starts rising, initially it will be red, then it will look orange, right? And gradually the color will become whiter and whiter. You will never see green color, but from red to white, gradually it will change because the color deflections are reduced as it comes closer to you. The less bending happens, right? So the answer is this: because red color experiences the least deflection or refraction, it re- it travels to the farthest point, and sun is at the farthest point during sunrise and sunset. So only red color is able to reach us. Other colors gets kind of lost. right?
Sir.
Okay, good.
Sir.
Next question. Another 1 marks question and the last one. The plot of the variation of potential difference across a combination of three identical cells in series versus current is shown below. Three identical cells in series. Cells are put in a sequence, one after the other. What is the EMF and internal resistance of each cell? What is the EMF and internal resistance of each cell? You see, this is a graph, voltage versus current. So somewhere there are three cells, okay? So what is the EMF and internal resistance of each cell? That is what is the question that you have. How will you get that? See, with voltage, higher the potential difference, lower the current. So point, suppose here is the point. Here the voltage is highest, right? This point, 6 volt, but the current is minimum, 0. Right? When the potential difference across the cell is 6 volt, current is 0. When the potential difference is 0, current is maximum, 1 ampere. Okay? So what is the EMF and internal resistance of each cell? EMF. So EMF will be equal to the voltage, total voltage divided by number of cells where the current is minimum, or current is minimum at it is 0 when the potential difference is 6 volt, right? And 6 volt, that means 6 volt is for 3 batteries, 3 cells together. So each cell has a potential difference or EMF of 6 by 3, that is 2 volt. Okay, and 2 volt. Now 1 ampere current is passing through each cell and that point the effective potential becomes 0. So what is the internal resistance? Volt by V is equal to IR. So R is equal to V by I, right? Ohm's law. So each cell has a EMF of 2 volt and current passing through that is 1 ampere when the effective voltage is 0, right? So 2 volt is getting compensated by the resistance, internal resistance, right? So 2 by 1, so 2 ampere is the 2 ohm is the internal resistance as well. So from the graph we'll get some values and that is what we have to use. 6 by 3 is the EMF of each, and then 2 volt is that EMF. Now 2 volt maximum current is 1 ampere. So EMF by maximum current. Again, this is 1 marks question, so don't expect too complicated answers, too many complications, right? Straightforward thing, and you can do these calculations without any worry that you will miss something which is important. Okay? All right, let's move to the next section, which is 2 marks question now. So you can expect a little more explanation or maybe more than one questions put together, related but more than one, or a little complicated calculation. So 3 things are possible. So here the first question is where multiple questions are put together. Multiple related questions are put together. 3 questions basically. Define modulation index. Why is it kept low? What is the role of a band pass filter? Now, which chapter has these things? Modulation index, band pass filter, communication system, right?
Communication system.
See, that is the first thing. If you don't know the answer, you will have to at least make an intelligent guess. What at least you should remember the topics, what chapters you have, and which chapter has no relationship with this word. Okay, so modulation is a term related to communication. Modulation, demodulation, modem, right? You have modem at home.
Yes, sir.
What do you do with modem?
Wi-Fi.
Yeah, for internet you are using modem, modem or router. Both are integrated together in your Wi-Fi device, modem and router. Basically, these are two devices but integrated, right? So modem is doing what? It is converting the analog signal into digital signal
Yes, sir.
and digital signal into analog signal. So modulation, demodulation, two processes are happening. Some on one way it is modulating, another way, the return path, it is demodulating, right? So that means it is about communication system, data transfer or voice transfer, any kind of data, voice or media, right? So the guess is yes, it will be present in communication system. So now I will ask you to go to that chapter. Do you have the book?
Yes, sir.
Part two. So go and find individually. You can find what is modulation index. To look for the reference of modulation index
Here
in
the
communication.
the process of superposition of low frequency signal wave on high frequency carrier wave.
Mhm,
That's, that is only modulation, sir.
mhm.
Index, index. Modulation is no, sorry. Yeah.
Amplitude modulation. So amplitude modulation, modulation index is called AM by AC.
Yes,
Here,
yes, sir.
here it is on this page number 525.
Change in amplitude of carrier wave by amplitude of carrier wave amplitude
Mm,
is equal to change in amplitude of carrying wave by amplitude of carrying wave amplitude.
right. Okay. So that is what is defined here. Okay. Now here on this page, the very first line, it says mu is kept less than or equal to 1 to avoid distortion. So that is the second question that is there. Why is it kept low? To avoid the distortion, right? So first and second question are very easily answerable here. Third part is band pass filter. So let's look for that. What is band pass filter? Now this I'm not finding any reference to these filters. So okay. Band pass, two different words. Here it is put up together. All right. Here is the band pass filter. Band pass filter.
Yeah.
A band pass filter does what? So here on page number 526 at the bottom, star mark, a band pass filter rejects low and high frequencies and allows a band of frequencies to pass through. So anything beyond the range, beyond the expected range, is filtered out. Lesser frequency and higher frequency. So that the data that you are getting or the signals that you are getting are in the expected band. Band means a range of frequency, start, minimum, and maximum frequencies that is defined, and then anything else lesser than that, either side, out of range is ignored, filtered out, right?
Yes, sir.
That is what is called band pass filter.
Sir, then what is the name of bandwidth, sir? Width.
Bandwidth.
Yeah,
Okay.
sir.
So again, band is what?
Band is the
Range, range, right? Range of frequencies or range of wavelength, whatever. These are waves, right? So communication waves, these are electromagnetic waves of various frequencies. Now that is not a fixed frequency, it's a range. It's a range. Now bandwidth is what is the range of, again, that frequency that is acceptable. Okay, that is called bandwidth. How much you can uh, handle is called bandwidth. Width means, width is the geometrical measurement, any wideness of something, right? Band's wideness or range of the band, right? Width of the band is bandwidth. From this point, so difference basically maximum to minimum is the bandwidth.
bandwidth.
Okay,
Bandwidth.
bandwidth. Okay, we will take this last question, which is talking about refractive index. A ray PQ incident normally means perpendicular on the refractive phase BA, this is the BA, in the prism BAC made of material of refractive index 1.5. So refractive index is the material that is inside this ABC.
Yes, sir.
Complete the path of ray through the prism from which face will the ray emerge. Justify your answer. Complete the path. That is step 1. And once you complete the path, you will know from which face the ray will emerge out. Will it go straight or will it come back and get reflected? So what is the path that it will follow? That is what you have to find out and justify your answer. Means, okay, if you think this is the path, how? That is the justification. So 3 things: draw the graph and find out from where it is emerging, coming out of the prism, and why. Okay. So you need to know the principles of refraction, 2 principles, Snell's law and the first law, which says incident ray, refracted ray, and the normal to the plane are in the same. Normal to the refractive surface is the same plane. And Snell's law says ratio. Sin I by sin r is constant. Okay. Now here, one thing that you will know, that if the incident ray is perpendicular to the surface, that is normal to the surface, angle of incidence is 0. And if angle of incidence is 0, angle of refraction will also be 0. What you will get is, well, there will be no deviation here on this surface. It will go straight. It will go straight and hit this point here. Now, this point here when it is hitting this point, it is not hitting it on a normal. Why? Because normal to this surface AC is like this, right? What you have to find is what is this angle. Which angle? This angle. this angle. Okay, so let me put it in a different color. This angle. Now, how will you find this angle? How will you find this angle? Okay, so let me extend this line and allow it to go through. Where, where is it running away? Okay, right? This point. Now tell me, what is the value of this angle?
30, sir.
This angle here, this one, the angle that I just drew, this one. See this red line and the base is parallel to each other, right? Because here it is 90 degree and here it has to be 90 degree. This particular angle is 90 degree. Then only it will be normal, perpendicular to this AC line. BC is perpendicular to AC. This red line is also perpendicular to AC. That means this red line and BC are parallel to each other. When these are parallel to each other, this angle and this angle, these two are corresponding angle. Corresponding angles are equal in value. In this case, parallel two lines, parallel lines, and a transverse. AB is a transverse to parallels. Suppose this point is X, or instead of X, let me write it as M. So QM, this QM, now this is Q, but say this is N, where it is cutting AB. Q is this point. Q is this point. Say MN is parallel to BC. Right? MN is parallel to BC. Right? So this angle NBC is parallel to ANM. These angles are equal. Now this is 60 degrees because this is 60, so this will be 60, and this is 90 degree, that is you already know. So the other angle, third angle, will be 90 minus 60. So this will become 30 degree, right? So this line PQ, which is going straight at M, it is making an angle of incidence I is equal to 30 degree, right? And you know refractive index. Now here sine I is now sine 30 degree, right? 30 degree. And sine R is not known because you don't know the angle R. But what you know is sine I by sine R. Sine I is not 30 degree, sine 30 degree. I is 30 degree, so I don't say sine I is 30 degree. Sine I is sine 30 degree. And sine I by sine R is something that you know. And what is that? Refractive index. So 1.5. Right? So you can find the value of R if you know. You know what? Sin I, right? Sin R will be equal to sin 30 by 1.5. Okay, so angle R can be found. Now, if you know somehow the angle R, that is the basis of how much deflection it will get. Will it follow this path? It will emerge directly from here, or it will be coming out here, it will go back here. All that will depend on what is the value of R that you are getting, right? Because that is the angle between MN extended and this line. So R will be this angle, right? So this is how you will get it. So this is the calculation that you have to make. Sin I by sin R is equal to refractive index, and once you get that, you will know this R angle. I angle you have already known, so you will be able to create the path. And once you are doing, while you are doing all that, you are already giving the justification. Why did you draw this line, right? So all three questions will be done in one go. All answers will be available. Okay, it's 8 o'clock, 8:05. So let's stop here today. What?
Sir,
Uh, no,
today you got it, sir.
uh-huh.
Today you got it, sir.
No.
Yes, sir.
Who said?